So in this case, the sequence that we are given or the number pattern that we are given falls under a quadratic sequence. So as we are given this question, I'm going to explain what is it that we consider under a quadratic sequence, under what we refer to as a quadratic sequence. So as we are given our terms, we can see from our question, guys, that is we are given to consider this number pattern, which is 3, 13, 31, 57, 91, and so on and so on. These are the terms that you're given. Like I was saying from our previous classes, that these are simply terms like T1, this is T2, this is T3, this is T4, this is T5, and so on and so on. So I'm going to use this example to explain what a quadratic sequence looks like and how are you going to approach that type of a question. So as we are asked here to determine on A, the general term for this pattern, this is your Tn, which we are not given there to say this is quadratic. Yes, under exam, they can specify. In that case, you're not going to waste your time trying all these other sequences. Just go straight to the quadratic. But in this case, we have to try, right? What is it that we are going to note on a quadratic sequence? One, okay, let's just have here our quadratic. So this is a quadratic sequence. So we are going to notice this time that we have a common second difference. So that's a pattern. So that's a pattern with a common, but it must be second difference. That's the first thing that you're going to notice. Meaning, as you are testing, you know your arithmetic. Supposed to consider T1, T2 minus T1, T3 minus T2, T4 minus T3, T5 minus T4. That is what you're supposed to work with. And see if there is a common difference between the first terms. So let's see. So you're going to have the difference here, the difference, the difference, and so on. So that's 13 minus 3. 13 minus 3, which is a 10. 31 minus 13, which is 18. 57 minus, so take note, 57 minus 31, which is 26. 91 minus 57, which is 34. We are seeing something that is unusual. This is unusual from what we expect. These are the differences, but they are not the same. We are supposed to have a common difference here if it was an arithmetic. That is what we know for an arithmetic. There's supposed to be a difference which is common throughout. But we see that it is not. But these are representing our first differences. So these are the first differences. I'm just going to write in short, first differences. But it's not the same. So what are you going to do? You find the second differences from this part. So yes, like you are forming a certain sequence here. It is just like you have formed another sequence or another number pattern. So this one, we have to see what is happening with this one. Okay, let's find our differences as we had before. 18 minus 10. Well, there's a difference of 8. 26 minus 18. There's a difference of 8. 34 minus 26. There's a difference of 8. So we can see that throughout these terms, there is a common difference. But it is happening what? For the second. So this is the second differences that we are talking about. The second differences that we are talking about, this is the one which is common. This is the common one. As we can see here, we said a pattern with a common second. This is the most important, second difference. So meaning to say the first difference is not common. So do not say under exam, you say, okay, the first difference is not common. Then you leave it like that and you say, no, this one does not exist. You try a geometric, you see, it's not a geometric. Then you say, this one does not exist. No, it is like that. You move on to the second. There will be a common difference there. Once you see that, once this happens, it follows that where, so it follows that from this quadratic, we are going to have our nth term, which is our general term, which is the nth term formula for Tn will be given as an squared plus bn plus c. Remember your quadratic, just like ax squared plus bx plus c. But we are no longer having x. In place of x, we are talking of the number of terms. X is now representing what? The number of terms. To say, okay, this is the first term, the second term, the third one, the fourth one, and so on and so on. So that is what is representing our x. Where in this situation that we just listed to say we have got an squared plus bn plus c, where 2a is equal to the second common difference that we are given. So that one is equal to the second difference. All right. So where 2a is equal to the second difference. So this is the first part that you need to take note. And the second part that you also need to take note, these are formulas that have been proven to work. So due to time, guys, I just need you to focus, just try to memorize these formulas. It can help you as you're working with the quadratic. We do not have time, like, okay. So the second one, it is about 3a plus b. There's a formula again that you need to memorize. This 3a plus b is equivalent to t2 minus t1. This is 3a plus b. So that is the first difference. T2 minus T1 represents this. The first term of the first difference is on the first difference is what is the first term that you are given. Then also you need to take note that we've got A plus B plus C, which is equal to the first term of the given, the original sequence that you're given, the first term, which is T1. So this is equal to T1, which is our first term from the quadratic. So this one, like I said, T2 minus T1, yes, it is the first term, but it is the first term of what? Of that sequence of the second, of the first differences, I mean. So this is the first term of the first differences of the first differences. I'm just gonna have this in short. This is the first differences. So the first term that you see there, which is your 10. Okay, this one, A plus B plus C is equal to T1. T1 is the first term from the original sequence. This is T1 of the original sequence. So this is the first term that we are given from the original sequence. All right, so this is from the original or from the original question, from the original sequence that we are given. That is our original question. So let me just have it here in short so that we do understand each other. So like I was saying, the 2a is equal to this part of the second differences. So this is the part that you're going to equate to 2a. All right. Then we move on. 3a plus b, which is T2 minus T1. 3a plus b, that is 3a plus b will be equal to this first differences, the first term of the first differences. Then we have got the a plus b plus c, it will be equal to T1, this one. That is how you just take it. So for you not to have confusion, just consider this part, all right? This one, the first ones. First, as you consider. Yes, does not matter to say you're going to equate because it's just 8, which is common throughout. But just for revision's sake, just consider like this, all right? So that you won't have a problem. So these are used, or these formulas are used to determine the values of A, B, and C. So let's start from the bottom going up. So we're going to start from the bottom going up. Remember, we said 2A is equal to what? To 8. So if 2A is equal to 8, it's an equation that you can solve for A. So let's solve for A, divide by 2. Divide by 2 both sides. So A is equal to what? A divided by 2, that's a 4. So meaning to say we can solve for A from there. It is an equation. You move on to the, as we are going up. So we move on to 3A plus B. Remember I said 3A plus B is equal to what? 10. The first term that we have of the first differences. But A is already there. We have already determined the value of A, which is a 4. So meaning to say we just need to substitute. 3A means 3 times A. 3 times what? 3 times 4 plus B must be equal to 10. Remember, this is our B. So it's an equation that we have formed with the B as the unknown. So you can solve for B because B is the unknown there. So these are the steps that you just need, right? So let's multiply 3 times 4. That's 10. So take the 12 to the other side. It is a positive. So on the other side, it is going to give us a negative. So it will be to be equal to 10 minus 12, which is minus 2. All right. So that's a negative 2 that you are going to obtain from there. So this is how we simply attempt our questions. We move on as we are going up. Here we are at this 3A plus B, now at A plus B plus C, which is equal to 3. So we're going to take that A plus B plus C must be equal to what? It must be equal to 3. So if it is equal to 3, therefore, let us substitute what we have calculated before, because we've got our A, we also have our B. So in place of A, in place of B, we are going to substitute what we have calculated. What is our A? Remember, that's a 4. So that's 4 plus our B, which is minus 2. All right, plus C is equal to 3. We solve for C. 4 plus minus 2 simply means 4 minus 2, which is 2. So that's 2 plus C, which is equal to 3. So that's C negative there. So that's going to be positive 1. So we are going to obtain the value of C as a positive 1 with the value of A, the value of B, and the value of C that we have determined. We must substitute. Remember, our Tn is given as an squared plus bn plus c. So we must substitute now into that formula, which is our general formula. Remember, we say Tn is equal to what? An squared plus bn plus c. So therefore, our nth term formula is going to be A, which is 4. So that's 4n squared. N represents the number of terms. So A, B, C are the constants to be substituted. So our B, that's a negative 2. So we're going to have this as negative 2n plus C, which is plus 1. So this is what we are going to have, which is a presentation of our Tn of the quadratic. Just like our normal quadratic equation, our normal quadratic function, y is equal to 4x squared minus 2x plus 1. So all the properties that you know about a quadratic function are the same properties also that you're going to apply on this quadratic sequence. You are from the understanding of a quadratic function also, because it is one and the same thing. So you must also be able to relate between the two. All right, so this is how you determine the general term, which is representing our Tn. Then from there, we are given, which is on B, calculate the 7th term of this pattern, remembering that our Tn is given as 4n squared minus 2n plus 1 as we calculated before. This is what we had. From the same Tn that we calculated, it is now a continuation to find the seventh term. You are told that n is equal to 7. So what is T7? In place of n, you substitute 7. So meaning to say, we'll be talking of the T7. What is its value, the corresponding value for that? So it's just a matter of substitution. In place of n, substitute the 7 that you're given. So that was going to be 4 into 7 squared minus, so that is our T7. And that was going to give us 183. All right, so just like that, you just need to work out as many questions as you can. Then if you're to consider this other question, you are now given which term is equal to 241. They are simply telling you that Tn is equivalent to 241. So which term? We are talking of n. Whenever I talk of the term n, what is the n value? The n that is corresponding. If Tn is 241. So how can we solve for this? Remember previously we calculated or we determined the general term. It's a continuation from there. Our Tn is, it was given 4n squared minus 2n plus 1. The same Tn is equivalent to 241. The same Tn that we're talking about is equivalent to 241. So what does it mean? It means these two, they're equal. It's an equation that you're simply forming from there. To say 4n squared minus 2n plus 1 must be equal to this Tn, which is 241, which is an equation where you have to solve for what? That is why I was saying, as you are working with a quadratic sequence, bear in mind of anything that a quadratic can happen. Is it a quadratic equation? Is it the property of a quadratic function? Because here we can see the highest exponent being 2, and we need to solve for n. That's a quadratic equation. Remember your quadratic equation. As you are solving your quadratic equation, I said ax squared plus bx plus c must be equal to 0. One side must be equal to 0. So we are forced to take the 241 to the left-hand side, which is going to be 4n squared minus 2n. The 241 is going to be a negative. So that's 1 minus 241, which is minus 240. All right, so it's going to give us a negative that's equal to 0. As you are to solve your quadratic equation, we can reduce this one. We can see that 2 will be the highest common factor between the terms that we're given. So you can even try to reduce this one by 2 each. So we're going to have 2n squared minus 2 and minus 2 cancels. That's minus n minus 1 or 2 as 0. Right? So having this quadratic equation, we can use our quadratic formula. It's up to you. As we know, from this quadratic equation, it can be solved with our quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. So you can use your quadratic formula. You can use a factorization. So this time we are no longer working with x. We are working with what? With n. So as you are solving your equation, you are going to specify to say what is the value of a, what is the value of b, what is the value of c, and it is solved in terms of n. As we can see that our a is going to be a 2, our b, the coefficient of x, which is the equation of n, c was going to be minus 120. I want you to use this one. If you are to use it, then use your formula as n is equal to, it's no longer x, it's n. If there is x here, you write as x is equal to. If there is m, you use m. If there is n, you use n. If there is p, you use p. So there is n. So that's minus b. The formula does not change. Minus b plus or minus the square root of b squared minus 4ac, everything over 2a. So I want you to substitute your values, use your quadratic formula as usual. You are going to obtain, all right, so let's just substitute. That's minus b, which is minus 1. So that's going to be minus 1 plus or minus, you're going to have it like this, squared minus 4 times a, our a, which is 220, everything over 2 times a, which is 2 times 2. So you're going to obtain 2, which is equal to negative 15 over 2. But as you can see, n cannot be a fraction. So our n was going to be 8. If you are using the quadratic formula, like I said, you can use the quadratic formula. But what about factorization? I explained in our grade 10, actually from grade 10, the factorization using the cheat method, the basic, all the factorization, guys, that you can think of, okay, not all, but most. So if you need any other factorization, guys, there are so many ways. Just check your previous grades, grade 11, grade 10, on how to factorize any method that you have been taught. Work with that one. So using the factorization method, I'm just going to explain my cheat method, the one that I explained most of the times. I said, you know that there are going to be two brackets because they're quadratic, right? So you know that you're going to have your two brackets. So you need the answers here, which you are not given how even they are, like, how do they even find this? And they just like give you the answers. Then you'll be wondering, where was this actually taken from? So using the cheat method, I said 2n squared minus n minus 120 like this. This is the part that you need to factorize. So you need to cheat this, remove these two, all right? You multiply it to the last term. You remove it totally. So it is going to be n squared minus n. This one, you remove it totally, it's no longer there. Remember I said you multiply it to the last term. So it is going to be minus 2 times 120, which is 240. Then you factorize this because you're now seeing that the coefficient of n squared is 1. This is the reason why, because of this 2, why we have to cheat this, because it's not 1. But as we can see now, there is a 1. So it follows that factorization is easier because we're just going to put n. We put n here. Then we focus on our constant, which is the negative 240, to say, what are the products of minus 240, which you add up to minus 1? Two numbers that you have. You multiply the two numbers, you get minus 240. Which of these numbers? But if you add the numbers, you must get a minus 1. So you're going to see that the numbers were minus 16 and 15. If you multiply these two, you're going to get minus 240. If you add these two, you're going to get minus 1. So that's minus 16 plus 15. So remember, you're using the cheat method. This is not our answer. What are we going to do? We are going to bring back the 2 that we stole and multiplied here. Now we bring it back wherever there is n. Wherever there's n, we are going to put that 2 that we had. So meaning to say, here we are going to put the 2. So it will be 2n minus 16. This will be 2n plus 15. Where possible, factorize on these two brackets. Where possible, factorize. The first bracket we can factorize because 2 is common here in the first bracket. So we can factor out the 2. That's 2n divided by 2, which is n, minus 16 divided by 2, that's a minus 8, and the 7 plus 15. The number that you just factored out becomes useless. We no longer need this part. It is not part of our question. It is the one that we're cheating with here. So we don't use it here. So this is what we're going to take. This is what we're going to take now. The two brackets that we just got here are the ones that they just write for you. N minus 8, this is 2n plus 15. Then you are wondering, where are these two brackets coming from? So like I said before, in any way that you have been taught that you understand on how to have these two brackets, guys, please use that. I'm not saying follow this. No. I'm not saying follow this. This is just a cheat method that you can use. If you understand it, if you learn, this one can be easier. Like I've seen, guys, it becomes much easier. These are just repeated steps. So if you do as many questions and just make sure that you do not forget your steps, it is going to be an easier way to do. But you can use a quadratic formula instead. We saw that. All right. So still we are going to obtain the same answers as we had from our quadratic formula. N minus 8 must be equal to 0. So n is equal to 8. You take the 15 to the other side, it becomes negative 15. Then you have to divide by these 2. Remember, we took the 15 there, so it gives us negative 15, but it will be 2n is equal to 15. So to find n, we must divide that one by 2. It was like this. 2n is equal to minus 15. So you simply divide by 2 by 2. All right. So n cannot be a decimal, guys. We're talking of number of terms. So definitely our n is going to be 8, meaning to say that is the corresponding part when our Tn is 241. The term is going to be the eighth term that we are talking about. So the eighth term is equal to 241. That is what it means. The eighth term is equal to 241. So this is it on your quadratic. Like I said, we just need to work as much questions. We are going to do that working with question papers so that you see how questions are given. Exam is different from a textbook, guys. Like I always say, exam is something on its own. You need to understand the mind of the examiner. So that is, you have to work as many question papers as you can so that you can see, okay, this is how they ask the questions and this is how I'm supposed to answer those typical questions. So that's it, guys. Till we meet again.